Hey everybody, you know driverless transportation is no longer just a futuristic concept. It's already happening across land, sea, and air. From autonomous cargo ships to military drones, here's 15 amazing driverless transportation systems. Starting with number 15, the X-47B from the United States. So the X-47B, it's one of the most advanced and important milestones in the development of autonomous military craft, designed to operate from the decks of aircraft carriers without a human pilot. Developed by Northrop Grumman under the U.S. Navy's Unmanned Combat Air System Demonstration Program, the X-47B isn't theoretical. It's a fully built, flown, and tested aircraft with real-world performance on both land and sea. Unlike remote piloted drones like the MQ-9 Reaper, the X-47B is a fully autonomous craft capable of taking off, landing, and conducting carrier-based operations using pre-programmed instructions with an onboard AI. While it does receive mission objectives and airspace constraints from a human operator, the aircraft navigates and manages flight controls entirely on its own. There's no joystick, no real-time remote control, and no pilot flying it manually. Two of them were built and first flew in 2011. One of the project's most groundbreaking accomplishments came in May of 2013, when it became the first autonomous craft to launch from an aircraft carrier, the USS George H.W. Bush. Just 2 months later, in July 2013, it made another leap by autonomously landing back on the carrier deck using the arrestor gear. That's an extremely complex task that had never before been performed by a drone. So let's look at the specs. It's tailless, jet-powered, and stealthy, with a wingspan of 62.1 feet, that's about 18.9 meters, and a maximum takeoff weight of about 44,000 pounds. It's got a top speed near subsonic and a combat radius of about 1,200 nautical miles. It also features folding wings, making it suitable for storage and movement on the constrained decks of an aircraft carrier. In 2015, the program reached another milestone when the X-47B successfully completed autonomous aerial refueling using a probe and drogue system. This achievement further extended the operational capability of future air combat systems, showing that they could remain airborne for longer missions without manual refueling. This craft proved that fully autonomous combat aircraft can integrate safely and effectively into high-risk, high-complexity environments, including carrier flight decks, air traffic control systems, and in-flight coordination with human pilots. While it may never see active duty, it remains a landmark in aviation history, a rare case where a vehicle truly operated without a human pilot from start to finish. Number 14, the Yara Birkeland, Norway. The Yara Birkeland is the world's first autonomous and fully electric container ship built in Norway to drastically reduce emissions and demonstrate the feasibility of a driverless maritime logistic. Developed through a partnership between the chemical companies Yara International and maritime technology firm Kongsberg, the Yara Birkeland represents a major shift in cargo transportation, both in terms of propulsion and control. The vessel was conceived as a solution to a specific problem. Yara International needed a cleaner, more efficient way to transport fertilizer from its plant in Porsgrunn to the port in Brevik, a journey of about 13 kilometers, that's about 8 miles by sea. Traditionally, this would have been handled by truck. About 40,000 diesel-powered trucks trip annually, but the Yara Birkeland was designed to eliminate those emissions entirely. The ship was launched in 2020 and it underwent various testing phases before officially entering service in 2022. It is classified as a zero-emission vessel, powered entirely by batteries with a capacity of about 6.8 megawatt-hours. That's equivalent to more than 100 Tesla Model S batteries. These batteries power electric propulsion motors and all onboard systems, which eliminates the need for any fossil fuel entirely. The ship is about 80 meters long with a gross tonnage of about 3,200 tons and can carry up to 120 standard shipping containers. It operates at speeds of up to 13 knots, and while its range is currently short by oceanic standards, it is ideally suited for short sea shipping between industrial zones. Now, while the Yara Birkeland currently has a crew on board during its transition phase, the long-term plan approved by Norwegian authorities is to operate the vessel fully autonomously with no human crew or captain. The regulatory pathway for unmanned cargo ships is still evolving, but Norway has been a global leader in establishing the framework. Critics have noted that while the ship is innovative, its impact is limited by its niche application and the short route. Nevertheless, it does serve as a proof of concept for a much broader industry transformation. The maritime sector is under increasing pressure to decarbonize, and autonomous electric vessels like the Yara Birkeland provide a viable path forward. As of 2025, the ship continues to operate, delivering thousands of containers per year with minimal human intervention and zero emissions. It remains the first and only cargo ship of its kind, but several projects around the world are now attempting to follow its lead. Number 13. TuSimple Autonomous Freight Trucks. TuSimple. It's one of the leading companies developing fully autonomous driverless freight trucks, specializing in long-haul logistics. Founded in 2015 with dual headquarters in San Diego, California and Beijing, China, TuSimple has been a key player in transforming highway freight with artificial intelligence and automation. Their autonomous trucks are based on an existing Class 8 tractor platform, most notably from Navistar and other manufacturers, but they're equipped with a full suite of proprietary sensors and software. Each vehicle includes a combination of LiDAR, radar, high-resolution cameras, and GPS localization, all feeding into TuSimple's autonomous driving system. This system processes huge amounts of real-time environmental data to make safe driving decisions, particularly on highways where the bulk of commercial freight operates. This system is designed to operate at an SAE Level 4 autonomy, meaning that the truck can drive itself without any human input under specific predefined conditions, usually limited access highways and fixed routes. Between 2019 and 2021, TuSimple operated an autonomous freight network with logistic partners like UPS, USPS on trial, and DHL, running autonomous trucks on routes between cities like Dallas, Houston, Phoenix, and Tucson. In a highly publicized demonstration in December of 2021, TuSimple completed what it called the world's first fully driverless semi-truck run on an open public road, an 80-mile route from Tucson to Phoenix, with no human in the vehicle, no remote control, and no intervention. Despite the achievements, though, TuSimple has faced some challenges. In 2022, the company experienced executive turnover, regulatory scrutiny, and increasing pressure from U.S. government officials over its operations in China. By mid-2023, TuSimple had laid off a significant portion of its U.S. workforce and announced that its intention to leave the U.S. market entirely and delist from the NASDAQ, although its China operations continue, along with partnerships in Japan and elsewhere. TuSimple's technology has never been deployed on a national scale or fully commercialized without any safety drivers, due to evolving regulatory frameworks and infrastructure limitations. Nevertheless, the company has helped pioneer the field of driverless freight, shifting the conversation from autonomous taxis to real-world cargo, a critical function in the global supply chain. Number 12. Park Shuttle. The Park Shuttle system, operating in Rotterdam in the Netherlands, is one of the oldest fully autonomous public transit systems. First launched in 1999, the Park Shuttle began as a pilot project and has since grown into a fully driverless operational transit service that connects an office park with the nearby Zoom metro station. The system is notable for its longevity, the operation on public roads, and the pioneering role in autonomous public transport. It uses small electric driverless minibuses, originally developed by a Dutch technology firm that specialized in automated transport. The vehicles run along a dedicated 1.8-kilometer or 1.1-mile track, making 5 stops and servicing Rivian Business Park. Each shuttle travels at around 15 to 20 kilometers an hour with a capacity for around 10 people. The system uses a combination of magnetic markers embedded in the roadway and an internal navigation system to follow its route precisely. In more recent versions, this has evolved to include LiDAR sensors, GPS, and vehicle-to-infrastructure communication for obstacle detection. The original pilot system, that was about 1999 to 2005, was replaced with a second-gen fleet that operated until 2019. And in 2020, an upgraded third-gen system was introduced, with more modern vehicles and partial mixed traffic capability. As of its latest upgrade, the shuttle now includes a section where vehicles briefly interact with normal road traffic while crossing intersections. That's a first for autonomous public shuttles. Safety is managed through dedicated infrastructure, including traffic lights, barriers, and vehicle-to-infrastructure alerts. Critically, the system's success lies in its narrow but well-defined scope, short distances, predictable traffic, and a closed or semi-closed operating environment. Planned future expansions include a connection to the water bus stop at Brain Park 3, further enhancing its multimodal connectivity. Number 11. Einride Pod. The Einride Pod is one of the first deployed autonomous electric freight vehicles designed to operate completely without a driver's cab. It was developed by Swedish technology company Einride. The pod, originally known as the T-Pod, isn't just driverless, it's designed to be undrivable by a human. The Einride Pod is a Level 4 autonomous vehicle, meaning it's capable of performing all driving tasks under specific conditions without any human intervention. While a remote operator can take control if needed, the vehicle is designed to function independently on predefined routes. Measuring roughly 7 meters long, the pod can carry up to 10 pallets or about 16 tons of cargo depending on configuration, and it's powered by a fully electric drivetrain. With a battery capacity of around 200 kilowatt hours, which gives it a range of about 200 kilometers or 124 miles on a full charge. The company's long-term vision includes mixed fleets of driverless pods managed centrally through this software, only with minimal human oversight. Einride pods first began public road testing in 2019 under a permit from the Swedish Transport Agency, making it the first vehicle of its kind approved for road use without a driver on board. Since then, the company's expanded operations into the U.S., partnering with major logistics and manufacturing firms like GE Appliances, Bridgestone, and Maersk. Einride's deployment strategy focuses on operating within structured environments first, areas where routes, interactions, and traffic are predictable. This has made pods attractive to companies looking to reduce emissions and operating costs on routine logistics tasks. While the pods are still not legal for general road use in most countries without remote monitoring, the technology has proven reliable enough for daily, real-world freight ops. The system's key value is not in replacing long-haul truckers, but in automating the middle mile and facility-to-facility segments of supply chains, which are often low-speed and repetitive. As of 2025, Einride continues to expand in both Europe and North America, and their pod remains one of the most radical examples of a fully driverless commercial transport in regular use. They've pushed the industry towards a future where driverless transport isn't just a possibility, it's already happening. Number 10. Rowboat. Rowboat is an autonomous watercraft project based in Amsterdam, developed in collaboration between MIT and the Amsterdam Institute for Advanced Metropolitan Solutions. Its design is to navigate the city's complex canal network without a human operator. Rowboat was introduced in 2016 as a long-term research project aiming to reduce urban congestion and pollution by leveraging underused waterways. The idea is simple, but technically challenging. Develop a self-driving boat that can autonomously pick up passengers, deliver goods, collect waste, or even reconfigure into temporary bridges. Each rowboat is approximately 2 meters by 4 meters, though different models vary slightly, and they use LiDAR, GPS cameras, and inertial measurement units to autonomously navigate. One of the standout features is the modular design. The platform can be configured as either a passenger shuttle, cargo carrier, or a waste collection boat. Multiple rowboats can even link together using a magnetized docking system to form temporary stages or pedestrian bridges. After years of small-scale trials and software refinement, Rowboat began full-scale pilot operations in 2021. Then in 2022, it demonstrated successful autonomous passenger transport through the Amsterdam Canal network. Each rowboat is powered by electric propulsion with a battery capacity suitable for about 12 to 24 hours of operation depending on the load and speed. It does travel at slow speeds, typically around 6 kilometers an hour. It's about 3.5 miles an hour, appropriate for safe operation in a busy canal environment. Rowboat is more than just a novelty. It does address real urban challenges. It offers an alternative that's emission-free, space-efficient, and scalable. It can be used for trash collection in narrow canals and for logistics in areas where trucks are banned. Rowboat may not yet be operating at full commercial scale, but it does prove that driverless systems can be deployed on water just as effectively as on land, especially in cities with dense canal infrastructure. As of 2025, the AMS Institute at MIT continued to develop Rowboat's software and hardware. With its blend of mobility and adaptability, Rowboat is set to become a central figure in the emerging field of autonomous maritime urban logistics. Number 9. AutoMine Autonomous Mining Trucks. Developed by Sandvik Mining and Rock Solutions, the AutoMine system is a deployed suite of technologies that enables driverless operation of heavy-duty mining equipment, including trucks and loaders. It's not a concept or prototype. AutoMine has been used in real mining environments across the world, from Australia to Chile, for over a decade. The system relies on a combination of LiDAR, radar, onboard sensors, and pre-mapped tunnel data to enable real-time decision-making. One of its primary challenges here is the complexity and danger of underground environments. Mines are dark, dusty, narrow, and subject to environmental hazards. AutoMine vehicles are built to handle this using redundant systems that allow them to detect obstructions and maintain safe distances. The system works by having a human-driven vehicle scan and map the mine's tunnel network. Now, this mapping data is then used to plan the routes and define safety zones. Once operational, the trucks operate in predefined autonomous zones where no humans are allowed to walk without triggering a system pause. Sandvik offers multiple versions of the system, including the AutoMine Underground for loaders and trucks and AutoMine Surface Drilling for above-ground operations. Their underground haul trucks can carry up to 63 metric tons of ore, all while navigating tight, low-ceiling tunnels on their own. These trucks can operate 24/7 with minimal downtime, resulting in higher throughput and lower cost. One notable deployment is at the Boliden-Garpenberg mine in Sweden, one of the world's most advanced zinc mines. The autonomous loaders here and trucks have operated alongside human workers using geofence separation, and it's helped the mine extend production to greater depths while maintaining safety standards. AutoMine is not exclusive to Sandvik vehicles. The company licenses the automation system for integration with existing fleets, making it an adaptable solution for various setups. It complies with any global safety regulation and has received approvals for autonomous use in multiple jurisdictions. Number 8. Zipline Drones. So Zipline is a drone delivery company that operates autonomous fixed-wing aircraft designed to deliver medical supplies, blood, vaccines, and essential health goods to remote or underserved areas. Launched in Rwanda in 2016, Zipline's technology is not speculative. It's been operating real-world, driverless delivery missions for years. Each Zipline drone is about the size of a large seagull, can carry payloads of up to 2 kilograms, that's about 4.5 pounds, over distances up to 100 miles round trip. The aircraft is battery-powered and launched using a catapult system, and once they're airborne they fly autonomously along pre-programmed routes to their delivery destinations, often rural health centers or clinics. When a drone arrives near its drop-off point, it doesn't land. Instead, it slows down, opens a bottom hatch, and releases the package using a parachute system. The drone then returns to its launch site, where it's caught mid-air by using a recovery wire mechanism. The entire round-trip delivery process requires no human intervention in the field, making Zipline one of the most advanced examples of driverless airborne logistics. Following the success in Rwanda, Zipline has expanded to Ghana in 2019, where it partnered with the Ministry of Health and the Ghana Health Service. The operation grew into one of the largest autonomous delivery networks in the world. In the United States, Zipline has partnered with Walmart, Novant Health, and Cardinal Health to deliver prescriptions, COVID-19 vaccines, and other medical supplies. The Zipline system uses automated flight planning and real-time air traffic avoidance, guided by onboard navigation systems and a cloud-based fleet management platform. Operators at Zipline's distribution centers oversee multiple drones from a single control room, but they don't pilot the craft. The entire operation is fully autonomous, from takeoff to delivery to recovery. As of 2025, Zipline has conducted over 800,000 commercial deliveries and logged millions of autonomous flight kilometers. The drones have proven to be extremely reliable, even in an adverse weather condition, and the company reports a 99.8% on-time delivery rate. Looking ahead, this company is rolling out its Platform 2 drones, which include precision drop capability to homes and businesses in urban and suburban settings. These newer drones feature vertical takeoff and landing ability and is designed to dock and recharge autonomously between trips. Moving on to number 7, Baidu Apollo Go. Baidu's Apollo Go is one of the most ambitious and operationally advanced autonomous ride-hailing services. Unlike experimental systems that remain confined to test tracks, Apollo Go has moved into real urban environments, carrying passengers in several major Chinese cities. Developed by Baidu, one of China's largest technology companies and a leading force in artificial intelligence, the system represents a major push to commercialize Level 4 autonomous driving at scale. The Apollo Go platform is part of their largest vehicle program, which began in 2017. Apollo includes open-source software, simulation environments, cloud infrastructure, and hardware integrations intended to accelerate the development of self-driving technology. The ride-hailing service specifically began pilot operations in 2020 and has since expanded aggressively. By mid-2023, Apollo Go is operating in cities like Beijing, Wuhan, Chongqing, and Shenzhen with a fleet of over 200 autonomous vehicles. In cities like Wuhan, Baidu received permission from local authorities to operate fully driverless robotaxis, that is, vehicles with no safety driver or remote operator. The robotaxis are used typically based in Baidu's in-house design or built on platforms like the Apollo RT6, that's a custom electric vehicle designed for operation. The autonomous driving systems integrate real-time mapping, object detection, traffic prediction, and behavior planning into a seamless AI-controlled platform. In cities with full approval for unmanned service, the vehicle arrives without a driver, and it opens its doors via app authentication. Baidu also has implemented in-vehicle voice assistance for communication and status updates, like confirming route status, identifying hazards, or providing estimated arrival times. Their vehicles operate on a mix of 5G networks and their proprietary V2X communication protocol that's vehicle to everything. These enable robotaxis to interact with infrastructure. The result is a smoother coordination at intersections and better awareness of real-time traffic patterns, especially in the complex, often congested streets of major Chinese cities. Safety remains a primary concern, and according to Baidu, Apollo Go vehicles had 0 traffic accidents in their first year of operations. However, it is worth noting that China's regulatory environment is highly localized. Their ability to deploy autonomous services depends on approval from municipal governments, and different cities have different rules governing things like maximum speed and geofence boundaries. In terms of reach, Baidu did report over 2 million cumulative rides completed as of early 2025, making the Apollo Go the largest fully autonomous ride-hailing operation in the world by number of completed trips. The service does continue to expand, with plans to cover 65 cities in China by 2026, and Baidu is also in talks to adapt the Apollo Go platform for overseas markets, although no international service has yet launched. Number 6. The ASV Global Seaworker 5. The Seaworker 5 is an autonomous surface vessel developed by ASV Global, now part of L3Harris Technologies, a defense and marine systems contractor based in the United Kingdom and the United States. This 5-meter-long catamaran-style vessel is fully unmanned and capable of operating in water environments for extended periods. It's equipped with onboard systems for navigation, obstacle avoidance, and mission execution. The primary use case is hydrographic and oceanographic surveying, where the vessel can autonomously perform missions like seabed mapping, pipeline inspection, or current measurements. It's powered by twin diesel engines that can operate for up to 7 days at sea, depending on its configuration and weather. It carries a suite of sensors and GPS navigation units. These allow it to carry out scientific surveys without manual piloting. Navigation is handled through a combination of pre-programmed mission planning, real-time GPS correction systems, and onboard collision avoidance, which includes radar and automatic identification systems. One of the primary advantages of the Seaworker 5 is that it reduces operational cost and safety risks. Traditional offshore surveying operations often require large vessels, which are expensive to operate and expose crew to weather-related danger. The Seaworker 5 enables 24/7 operation with lower fuel consumption and no need for any onboard living quarters. It supports multi-vessel operations, meaning it can work in tandem with larger manned or unmanned vessels, sharing data and acting as a node in a broader system. This is especially useful in larger-scale operations like mapping ocean pipelines or monitoring undersea cables. The vessel's been tested in harsh environments, including the North Sea and other offshore regions, demonstrating its ability to operate independently in moderate seas and varying weather. The company have since expanded the Seaworker line to include larger and more specialized variants, but the Seaworker 5 remains one of the most versatile and widely used models. It bridges the gap between small academic survey drones and large naval USVs, offering a scalable and flexible platform. Number 5. The Navya Autonom Shuttle. The Navya Autonom Shuttle is fully autonomous. It's an electric vehicle that's designed for short-distance public transit in controlled or semi-controlled environments. Developed by the French company Navia, this shuttle represents one of the earliest efforts to commercialize Level 4 autonomous transportation in urban and suburban settings. It requires no steering wheel or driver's cabin and is built to function completely without a human driver. Launched in 2015 and refined over successive generations, the Navia shuttle is a 12-passenger vehicle that operates at low speeds, generally capped at 25 kilometers an hour, that's about 15 miles an hour, and follows pre-mapped routes. The vehicle is bidirectional, meaning it can travel forward and backward without needing to turn around, which is useful in tight spaces and loop routes. The shuttle is typically deployed in campuses, business parks, hospitals, city centers, and airports, where road environments are controlled and pedestrian activity is predictable. Among its most notable deployments are pilot programs in France, Las Vegas, and Oslo, Norway. These pilot programs often involve real passengers using the service as part of a routine transportation and monitored by remote operators. In 2017, Navia conducted one of the first-ever driverless shuttle trials on public roads in the U.S. The shuttle operated on a loop in downtown Las Vegas and carried over 250,000 passengers over the course of its testing period. Although some operations experienced minor incidents such as low-speed scrapes, no major accidents happened, and the tests helped validate the technology's safety in real-world settings. The shuttle doesn't operate in a dynamic decision-making in the same way that some self-driving cars do. Instead, it relies on a fixed virtual route that has been pre-mapped using a high-definition scan. While this limits its flexibility, it does allow for greater control and predictability. By 2025, Navia had completed over 600,000 kilometers of autonomous driving worldwide and was among the few companies to have multiple autonomous vehicle models, shuttles, and logistics in simultaneous use. While it did file for court-led financial restructuring in early 2023 due to funding difficulties, the core technology and services have been maintained, and several regional partners have continued limited operations. Number 4. RoPax, Autonomous Ferry of Norway. In the waters of Norway's Oslo Fjord, autonomous maritime technology is undergoing real-world testing and early deployment through a project that may shape the future of short-distance marine transport. The RoPax autonomous ferry is being developed and operated by Bastofossen, one of Norway's largest ferry companies, in collaboration with Kongsberg Maritime, a leader in maritime automation systems. The project centers around the Basto Electric, a 139-meter-long battery-electric ferry that operates on the Horten-Moss route, one of the busiest ferry corridors in Norway. The term RoPax refers to roll-on, roll-off, or ro-ro passenger vessels. These are ferries that transport both vehicles and people. The Basto Electric can carry over 200 cars and 600 people, making it one of the largest vessels in the world with an autonomous navigation system installed. The autonomous control system consists of a platform which integrates sensor fusion, route planning, and automatic docking, and that allows the ship to maintain course, adjust for current and wind, and approach the quay with precise control. Remote monitoring is conducted from an offshore center, where operators can supervise operations and intervene if necessary. Importantly, the electric autonomous systems here are not prototypes, but they're operating in a commercial environment on a fixed schedule with real passengers and vehicles on board. This does place it ahead of many other autonomous projects, which remain in research or closed test phases. Norway is among the world leaders in crafting policy frameworks for autonomous shipping. The RoPax ferry program is providing data that could help inform changes to maritime safety codes, crew requirements, and traffic controls. Safety is a central concern of the program. The system includes multiple levels of redundancy, dual navigation systems, backup power supplies, and fail-safes that return control to a human in case of an error or system failure. The vessel is also equipped with advanced automatic identification systems to detect and track nearby vessels, buoys, and floating hazards. Combined with radar and optical sensors, this system creates a real-time 3D map of the ferry's surroundings that it uses to make navigation decisions. Number 3. Autobahn in Germany. The Autobahn is a driverless elevated transportation system under development in Germany that proposes an innovative alternative to urban mobility. Designed to carry individual or small group passengers in autonomous electric pods, Autobahn vehicles run on overhead tracks, merging the functionality of autonomous cars with the efficiency of a rail system. Unlike traditional public transit systems that operate on fixed schedules and routes, Autobahn aims to deliver on-demand personalized transport using AI-based routing and dispatching, without human drivers or onboard attendants. Headquartered in Munich, the Autobahn project began in 2019 with the vision of developing a climate-neutral, space-saving, and highly flexible system. By moving the transport infrastructure above the street level, Autobahn eliminates the need to build new roads or disrupt pedestrian and vehicle flow at ground level. At the system's core is a network of elevated guideways upon which autonomous pods travel. These pods are suspended beneath the track, similar in concept to a monorail, but with key differences. Each pod is individually powered and routed, allowing them to bypass stations or slower traffic and head directly to a selected destination. Each Autobahn pod is electric, self-driving, and can carry up to 4 people. The pods are summoned through a mobile app, much like a ride-hailing service, and passengers board from dedicated access points along the guideway. From an operational standpoint, the pods are guided by embedded systems that control acceleration, deceleration, routing, and station docking, and because the vehicles are separated from street traffic, the system eliminates the possibility of any collisions with cars or pedestrians. Autobahn has already taken tangible steps towards deployment. In 2022, the company received approval to build its first test track in a municipality in the Munich district. The 900-meter-long test line is intended to validate the system's technical feasibility. The test track will also function as a showcase for investors, urban planners, and regulatory authorities. The Autobahn system is 100% electric, and the company claims that it's significantly more energy efficient per passenger per kilometer than traditional cars or buses. According to Autobahn, the system's smaller footprint allows for green strips underneath the guideway that can be used for parks, bike paths, or pedestrians. While the system is still in development and testing phase, it represents a concrete example of a driverless model that combines autonomy and urban integration. It's one of the few systems that aims to blend on-demand flexibility with fixed-route infrastructure, which is going to create a hybrid between personal transport and public transit. Number 2. Skyborg Autonomy Core System. The Skyborg Autonomy Core System, or ACS, is an advanced driverless aviation initiative developed by the U.S. Air Force to enable autonomous flight capability in unmanned craft. Unlike a conventional drone program tied to a specific airframe, Skyborg is designed as a modular and transferable brain of sorts, allowing it to operate various types of uncrewed aerial vehicles. This flexibility makes it a critical piece of the U.S. military's strategy to integrate autonomous systems into modern combat ops. It was officially launched in 2019 as part of a broader U.S. Department of Defense push to accelerate AI and autonomous warfare. Skyborg is considered one of the 3 pillars under the U.S. Air Force's Vanguard initiative, which focuses on high-priority research projects. The core goal of it is to develop an autonomous control system that can pilot a UAV safely and effectively in dynamic environments. It's not a fixed aircraft platform, but a software and sensor suite designed to be installed in a variety of airframes. These can include drones, inexpensive, expendable aircraft used for high-risk missions, as well as more advanced combat platforms. The architecture of the system allows it to operate in concert with fighter jets in a loyal wingman configuration, where autonomous drones fly in formation with piloted aircraft and take on support roles like reconnaissance, electronic warfare, or even weapons delivery. The system reached a major milestone in April of 2021 when a Kratos UTAP-22 Mako drone successfully flew a test mission using Skyborg ACS. During the flight at Tyndall Air Force Base in Florida, the drone operated autonomously for 2 hours, demonstrating safe navigation and mission execution. Further test flights used additional airframes like the General Atomics MQ-20 Avenger and the Crate Defense Systems Valkyrie XQ-58A, which expanded the flexibility of the platform. Another distinctive feature of Skyborg is the focus on open architecture. This means that developers can integrate new sensors, weapons, or software into the system without requiring a complete redesign. This modularity does allow the system to evolve alongside advances in drone design and mission requirements. The U.S. Air Force has also emphasized the importance of ethical AI, incorporating protocols to ensure that autonomous systems behave within defined boundaries. As of 2025, the Skyborg program remains in advanced testing and development. Though not yet fielded for active combat missions, it's already been demonstrating core competencies in autonomous takeoff, navigation, teaming, and landing. It is expected to play a major role in the future of air combat, reconnaissance, and electronic warfare, in scenarios where maintaining air superiority involves deploying large numbers of fast, inexpensive, and expendable systems. Number 1. The Boeing MQ-25 Stingray. Possibly the best name so far, the Boeing MQ-25 Stingray is a carrier-based autonomous aerial refueling drone developed for the United States Navy. It's designed to extend the range and endurance of manned fighter aircraft like the FA-18 Super Hornet, the EA-18G Growler, and the F-35C by refueling them mid-air without a human pilot on board. The MQ-25 is the Navy's first operational carrier-based unmanned aerial vehicle, or UAV, and it represents a major shift in naval aviation. This program was born out of a series of earlier Navy initiatives like the Unmanned Carrier Launched Airborne Surveillance and Strike, or the U-Class program, which was ultimately reconstructed to focus on more specific and achievable goals, aerial refueling being one of them. This streamlined vision became the Carrier-Based Aerial Refueling System, or CBARS, which prioritized developing a UAV that could take off and land on an aircraft carrier. And Boeing won the development contract in 2018, and the resulting craft was named the MQ-25 Stingray. In a series of successful tests beginning in 2021, the MQ-25 performed multiple aerial refueling missions with Navy fighter jets, demonstrating its ability to work seamlessly with a wide range of current-generation craft. The first flight of the test article, known as T1, took place in September of 2019, and its first successful in-flight refueling was achieved in June of 2021. Now, what makes the MQ-25 significant is that it's intended to launch and recover autonomously from aircraft carriers. That's one of the most complex and hazardous flight operations in any military domain. That integration is essential because it enables carrier flight deck crews to operate the MQ-25 using similar procedures and interfaces. The MQ-25 is powered by a Rolls-Royce turbofan engine, the same engine used in some business jets, which provides sufficient thrust and endurance for its mission profile. The drone has an estimated range of about 500 nautical miles while carrying 15,000 pounds of fuel, making it a major force multiplier for air carrier wings. In addition to its primary tanking mission, it's being designed with modular adaptability in mind. Future variants or payload options may allow for intelligence, surveillance, and reconnaissance tasks, communication relays, or even electronic warfare missions. However, the Navy's current procurement focus remains on operationalizing the tanking capability first. As of early 2025, the MQ-25 is still in the test and early production phase, with Boeing contracted to deliver a series of test craft and eventually a fleet of over 70. Carrier integration trials have continued aboard vessels like the USS George H.W. Bush, that's CVN-77, where the flight deck operations, taxiing, and control system interfaces are being refined. The MQ-25 Stingray, it does represent a practical and strategic application of autonomous aviation.